So having the use of AutoCAD has given me quite a lot of insight into the geometry of the solar system and the Sun-Earth relationship that other people perhaps don't have, and I'd like to share some of it with you today. So what you're looking at here is the plan view of the Earth, the sphere Earth. So this would be the North Pole. The red line, well, certainly east of the centre, this portion of the red line is the meridian line, so that runs through London, and it's the line at which GMT time is taken from as a reference. The yellow line around the edge is the equator, and if I go to a 3D view now, so yes, the yellow is the equator, the blue is obviously the Earth, and the red is the meridian line at which all other longitudes and latitudes, or certainly longitudes, are referenced from. So if I turn on a set of coordinates which is close to my hometown in the UK, which is the green here, so my hometown is slightly west of the meridian line running through London. It's actually 0.842 degrees west, so that would make it a minus longitude, since it's west of the meridian. Anything east of the meridian is a plus figure, so this is actually minus 0.842 degrees. And the latitude up here, taken from this sort of point on the equator, is 53.0627 degrees. So where that intersects with the surface of the Earth up here, at this point, that is my hometown. So if I freeze that one, I took a point in Africa, in Pretoria in Africa, which is the purple here. Let's look at those coordinates. So from the meridian line, from the red line, it's 28.238 degrees, and that's a plus because it's east of the meridian, and it's actually below the equator because it's in South Africa, so the dimension there below the equator is 25.7487 degrees, which is this point here in South Africa. Let's freeze that one. I then took a place or a point in Sumatra near Kuala Lumpur. Now this point is just above the equator, and it's quite a large longitude. It's 97.829 degrees from the meridian to this point here, and it's plus 3.1086 degrees above the equator. So that point there is a point near Kuala Lumpur. I chose them because all three of them make sort of a large triangle, and that's the whole point of what I'm trying to do here, and that's triangulate the Sun based on three positions on Earth using exact geometry. Next, I use this website. It's www.suncalc.org, and what this allows you to do is to pick coordinates anywhere in the world, and over here it gives you an altitude and azimuth of the Sun position from that particular location on Earth. So I've got it set already to zoom into my hometown just here. I've put the exact coordinates in, which are shown down here, the longitude and latitude, just here, and it tells me that on the 21st of June 2015 at 8 o'clock UTC plus 1 hour, the altitude was 26.59 degrees and the azimuth was 85.71 degrees. Now, just one thing to note, that this is completely based on spherical geometry and spherical calculations. So everything that this website is telling us is based completely as if the world was a globe. So the results are going to be similar to that. So first of all, let me explain what the altitude and azimuth here refers to and how I worked it out, or how I drew it in AutoCAD. So in order to determine the sun's location from an observer, you would draw an imaginary circle around yourself, like this. You would face north, and then you would turn from north to an angle here, which is called the azimuth, and wherever the sun was would be the azimuth angle. And similarly, the altitude angle would be the angle from the horizontal, or from the horizon, upwards to the star, or the sun in our case, and that is the way you determine the sun's location from a particular observer on the Earth. So to show this, I've drawn the circle from my hometown location. I've drawn a north line here, which points at the North Pole up here, and from the website, the suncalc.org website, it told me that my location is 85 degrees, or sorry, the sun's position from my location here in the centre is 85.71 degrees. So I've gone in an eastward direction, clockwise. That gives me this line here, and then so that's the azimuth. Then the altitude is the angle formed between this horizontal 85.71 degree line and the line of sight up towards the sun. So just spin it around a bit so you can see it a bit better. So they're the angles we're talking about, and that's how I am determining the sun's location on all three points on the Earth. Okay, let's skip to Africa. So here we are in Pretoria in South Africa, and the altitude is 22.75 degrees and the azimuth is 47.05 degrees. So let's go back to the globe, and here's South Africa, and the azimuth is 47.05 degrees and the altitude just there is 22.75 degrees. So that's how I've determined South Africa. Bring it back around again. Let's look at Kuala Lumpur. So this is near to Kuala Lumpur over here. It's this North Sumatra area, just a random place that I picked. And the altitude is 60.4 and the azimuth is 315.36 degrees. So let's have a look on the globe. There it is in orange. So the azimuth is 315.24 degrees all the way around to here, and the altitude from that point is 60.34 degrees. So let's see where the lines of sight converge, or not, as the case may be, 93 million miles away. Okay, so this that you can see here is the path through the sun from the Kuala Lumpur location that we've just looked at. So if I click on that line, it tells me over here, look, it's 93 million miles. And the sun is drawn to scale as well, as was the globe, by the way. And so the sun, if I click on that, it's a sphere with a radius of 432,700 miles, and a diameter of 865,400 miles. Let's turn on the other lines of sight. So we've got that one, and we've got that one. I think that's all of them. Yes. So we've got the green, which is my hometown. We've got the purple, which was South Africa, and we've got the orange here, which was Kuala Lumpur. And you can see they don't quite converge. If I take a distance from the end point of the South African line of sight and take it to the end point of the Kuala Lumpur, it is a distance of 152,000 miles apart. But it still falls within the confines of the Sun, as it's so large in the globe model. So just to show what they look like all together from the globe, there are the lines of sight from all three locations. This view here is looking behind the Sun, or from a position behind the Sun, looking back at the Earth. And as you can see, the lines don't actually converge at all. They just get further and further apart. So this distance here was that 150,000 miles that we just measured. But what I'm trying to show here is that I have actually got the capability to model this very, very accurately. But I will need some help. And what I'm going to ask for is for at least 2 people, myself as a third, but preferably 3 other people, who have the means and the capability of determining azimuths and altitudes to the Sun with whatever equipment you may have, and to coordinate yourselves so that you can get the angles documented at the exact same time of day in all 3 locations, and get them back to me, and I can punch them into this model and determine exactly what's going on. Because I've also done a flat Earth version of this, which I'm going to show next. And I believe, since the website that I've just been looking at is based completely on spherical geometry, this model here that I've just shown you is going to work all the time. However, nobody has actually meticulously gone through every single location on Earth and documented where the Sun is at that particular location, and formed it into some sort of database. It's all done on mathematics, sphere-based mathematics and geometry. So if it's out, and I can't really determine whether it's out or not with the equipment I've just simply got a compass. But I know there is equipment out there that can be used, and I was just hoping 3 people will be able to send me the data that they collect at the exact same time of day from 3 different locations on the planet, necessarily with sunlight available at all times, at all 3 times. We can't have it where one person's in darkness. They all have to experience sunlight at least at some point at the same time. But if they can get that to me, it will be much appreciated, and I will collate it and draw the model, and we'll see once and for all what shape the Earth is that we live on. Anyway, let's get to the flat Earth geometry. So this is the Gleason's new standard map of the world, which I've imported into AutoCAD. I've traced over the lines of latitude here with circles in AutoCAD, and because it's been scanned, the lines don't actually match the circles precisely, but they're not far off. I then offset this circle by a distance which I determined by using Google Earth and measuring distances between places and scaling this map up accordingly so that it matched, and I made sure I used places in the northern hemisphere because I know that the southern hemisphere might throw it out a little bit. So I drew the meridian on here, which is the red line again. The yellow line is the equator. These lines are all 15 degrees apart, so from the equator we've got 15 going up, and then from the equator we've got 15 going down towards the southern hemisphere. So I drew my hometown location again, west from the meridian. I drew South Africa in the southern hemisphere, counting down from these lines to whatever degree it is. I divided this distance between these lines of latitude into degrees and placed South Africa on that degree, and similarly with Sumatra or Kuala Lumpur just over here. And these angles here, you can see the orange angle here, which is the longitude angle, is 97.83, and for Africa 28.24 degrees, and then for my location it's actually minus 0.84 degrees. And as you can see, they work out pretty good on the map. There would be, the red line would be going through London as the meridian. There's my location. That works out in South Africa, and that works out in Sumatra. It's pretty accurate. I then drew the line of, or the angle of azimuth. I'll tell you what, I'm just going to turn the map off because it slows panning down when I'm going into 3D. So here would be, this would be north, facing this way. So measuring an angle eastward from north, going around this way, this would be the azimuth angle, and then up from that angle would be the elevation or the altitude angle here, which points off up into space. I did that on all three, and as you can see, none of them converge, as is expected since I've used the SunCalc website's spherical based calculations, so I wouldn't really expect these to converge. As you can see, none of them do. I've drawn the sun in there at the flat earth scale of 23 miles in diameter. So what I would ask for is the coordinates from around the world to the sun, or sorry, the angles to the sun from different places around the world. And let's see if we can get all three lines to converge to a single point, i.e. the sun. And if we can't, and it turns out that the values and the angles on the SunCalc website and others like it are in fact correct, then I will have to concede that the world, or the Earth, is a globe. That's not to say that I would completely abandon all my research into things like the ISS. I'm not sure if anybody's listened to the Mark Sargent interviews with the two Navy guys, one from a nuclear sub, the other from a ship, a military ship. But they have some fascinating insight into what life is like aboard a vessel for long durations of time, and what would be required and what is required to maintain such vessels, such as machine shops with drill presses, lathes, milling machines, so that they can fabricate parts that they may need that have failed in an emergency to stop, the boat sinking or to stop the submarine malfunctioning. There's things like the parts that are required, seals that need replacing, valves that need maintaining, a whole manner of things that I don't believe are available on the ISS. There's certainly no machine shop as far as I know, and the ISS has now been in operation continually for 15 years. Well, it will be next month. It's actually the 15-year anniversary this November. Perhaps we should throw them a party, giving thanks to them for all the wonderful things that they've done for humanity in the last 15 years. Maybe they can finally come out and explain to their Navy comrades in the submarines how they make fresh air, and how they've been making fresh air for 15 years. As far as I'm aware, the submarines have to surface every so often. They can't stay underwater indefinitely. It seems like a logical step to me for the ISS technology to be adapted into submarine technology. They could stay down there indefinitely then. But I won't hold my breath, pun intended, and I won't hold my breath for a better proof to come along to either confirm or deny the existence of a globe as to what I'm proposing here. So if you can send me some data in, I'd ask you to be as accurate as possible, maybe to the nearest half degree if that's possible, I'm not sure. Elevation above mean sea level would be more accurate as well. Maybe if it does turn out to be a flat plane, we can build up a database, taking lots of readings, see how the sun actually does move. We could perhaps do the moon as well. I'm out for truth here. I've got to know for sure, and as I'm sure a lot of other people out there want to know. So I'm perfectly willing to share this AutoCAD file with anybody who wants to see it, to verify what I've drawn is correctly, if anybody's able to use it, or I can save it in various different formats for people to use if they can import it into a different vector-based drawing program. So looking forward to hearing from people. Send me a message. Thanks for watching.